Okay everyone, we are here to discuss the basic concepts in geometric dimensioning and tolerancing. The things that we are discussing here are maximum and minimum material conditions, the datum, that is reference that we need to define GD&T symbols. So why we need GD&T symbols, that we need to understand first, because whenever you want to manufacture your product, you need to give a drawing, which we call it as engineering drawing, which will come with some dimensions and which will come with some form that we call as shape. So from a manufacturing point of view, when the product is mass manufactured, it is very difficult to manufacture the product all the time with correct dimensions and with correct shape. So that's why, to avoid this, we give some tolerances in the form of tolerances on geometry and tolerances on dimensions, that we call it as GD&T. So in GD&T, it is very essential for an engineer to understand what is basically your maximum material condition and least material condition before going further. So maximum material condition, that we call it as MMC, is nothing but the condition where maximum amount of material is present. For example, if you take a shaft whose basic size is 30, and on that you have given tolerance of plus minus 0.2. So this plus minus 0.2 is called as dimensional tolerances, where if you add plus 0.2, your upper limit will become 30.2 and lower limit will become 29.80, right? So as a manufacturer, you're allowed to manufacture in between 29.80 to 30.20, right? So this 30.20, where you will get maximum amount of material, is called as MMC, whereas 29.80, where you will get least amount of material on that particular shaft, is known as least material condition. We'll explain through one example. So here you can see a shaft whose basic size is, say, 2, right? So this is your basic size. On that basic size, on an upper size or on a higher side, we have given a tolerance of 0.07, and on lower side we have given a tolerance of 0.03. So this 2.007 will be known as your MMC, and 2.003 will be known as LMC. See, this is the proper diagram where you can see the maximum material condition, that is MMC, of this particular shaft, and 2.003 is your low material condition. So what is the significance of this LMC and MMC? LMC and MMC are nothing but your maximum size of the component that is allowed, and LMC is nothing but the lowest size of the component which is allowed when you are manufacturing that component within geometric tolerances. As I mentioned earlier, it is quite difficult for a manufacturer to manufacture a component of same size every time. You cannot go on manufacturing a component of, let's say, 2 mm or a shaft of 2 mm or a hole of 2 mm every time. That's why, as a manufacturer, I need some sort of tolerances on the dimensions. Those tolerances are nothing but your geometrical tolerances. Similarly, on shape also, we need some sort of tolerances. Okay, so I hope you have understood this this concept of MMC and LMC. We will discuss the geometrical aspects in the next video. Thank you. Okay, so like we have tolerances on dimensions, we also have tolerances on shape, or we call as geometrical features. So in this particular table you can see category of the features like form feature, profile feature, orientation feature, location, and runout. So let's discuss about form feature. So if straightness is a form, flatness is a form, circularity of a cylinder is a form, cylindricity of a shaft is a form. So this type of features in the engineering drawing will be represented by the symbols. In a drawing, a straightness will be represented by a straight line, flatness of the object will be represented by this particular parallelogram, circularity or cylindricity of the shaft will be represented by this particular symbol. So if you see such type of symbols, you should understand that a person who has made this drawing is discussing about geometrical features like straightness, flatness, circularity, cylindricity, etc., etc. Like the most common symbols that we have been studying from our childhood days, like parallelism. So if you see such symbol, you definitely know that the person is talking about parallelism. If you see the symbol like this, you definitely know the person is talking about perpendicularity, right? So again, in the drawing, like orientation symbol, you have location symbols as well. Like if this symbol is there in the drawing, you should understand that the person is trying to talk about the position of a center, maybe position of a hole, maybe, etc. Like if there is a symbol like this, two circles, so this symbol is concentricity. Like if there are two circles drawn, so there must be two shafts or two things whose center is same. That is what you should understand from these symbols. Okay, so these symbols are mentioned in a feature control frame. In a drawing, there will be a feature control frame. This feature control frame is mainly divided into three parts. It is a rectangular feature frame, that you can see here. So first part is dedicated to geometrical feature that you want to elaborate or you discuss. Second part, or the second part of this rectangle, is talking about the dimensional tolerance. And third part, where you can say this ABC, is talking about the datum. So I'll explain this rectangular feature frame first, because the knowledge of this thing is very important while reading out the GD&T symbol. So if you see a symbol like this, let's say the symbol here is of position. So as a reader, I should understand that the drawing is about mentioning the position of a center. Okay. Second is regarding the geometrical tolerance, which is of 0.02 on a diameter, and this symbol is for maximum material condition, that is MMC. And here A is your reference, primary reference, B is your reference, secondary reference, C is your tertiary reference, because whenever you are defining geometrical tolerances, you may need to define the references with respect to which feature or which reference you want to define those geometrical tolerances. Like see how to read it out, this particular frame. So the explanation here is the position of the feature. Position is this. Feature must be within 0.03 diametrical tolerances, second frame, at maximum material condition relative to datums A, B, C. Like if you want to define the position of a hole with the diametral tolerances of 0.003, it should be defined with respect to three references A, B, C. So references are three because you have XY plane, XZ plane, and YZ plane. That's why we need three references to define a 3D object. Okay, that's why this frame is talking about. So in the drawing you will see geometrical tolerances defined in such type of frames. Okay, so So to discuss more about geometrical tolerance or geometrical features, here are some examples. So here is a rectangular plate that you can see whose top surface I want to talk about. I want to talk about the feature of the top surface. So as a manufacturer requirement, the top surface of this plate should be flat. So that is written, or that is shown in the form of GD&T symbol like this. See, this symbol is of flatness and second is the tolerance. So what this feature frame is talking about? This feature frame is talking about the geometrical aspect of this rectangular plate, that is flatness. So while maintaining the flatness of this object, tolerance should not exceed the value of 0.005. That is what a person who has made the drawing wants you to know. Similarly, let's say this is the second thing that is there. So here the angle is 45 between the two surfaces. So this is bottom surface, this is top surface. So angle between bottom surface and top surface is 45. It should be 45 always, but see, while manufacturing, it may be or it may not be 45 degree. So for that, to compensate the manufacturing error, I am giving a geometrical tolerance with the name of angularity. So I am trying to specify the tolerance on angle with what value? 0.003. So here angle needs to be given a reference, because whenever we measure an angle we give a reference, right? So here I have defined this bottom surface as a reference, which I am calling it as a primary reference. So the meaning of this rectangular feature frame here is on 45 degree angle 0.03 tolerance is allowed, but with respect to reference A, right? Similarly, let's talk about this object, this symbol. This symbol is for cylindricity, right? So this is a shaft which is supposed to be cylindrical, whose diameter is 1 mm. That is what the drawing is saying. But let's say I want to manufacture hundreds of shaft with diameter of 1 mm. But again, it's not possible to maintain the cylindricity, which is one of the aspect of a round objects, cylindricity. So to give a tolerance on a geometry, I am saying that I am okay with the tolerance of 0.02 mm on the cylindricity of this shaft whose diameter is 1 mm. That is what I am trying to convey you. So GD&T symbols are nothing but it's a message to a person who is trying to read the drawing. Okay. See, this is a rectangular plate again. On this rectangular plate I want to make a hole. Okay. So the hole diameter is 0.500. Okay. On this 0.500 I am giving a tolerance of 0.005, which is on upper side as well as lower side. So that means this particular thing is nothing but dimensional tolerances, which I am giving because every time it is not possible to drill a hole of 0.500. That's why I am giving a tolerance of plus minus 0.005, right? Similarly, along with dimensional tolerance, I am giving geometrical tolerance, which is talking about the position of this hole, right? So this symbol is of position, which is talking about the position of this hole should be given a diametral tolerance of 0.003 for maximum material condition with respect to reference A, which is your primary reference. So this is how a person can read dimensional tolerance as well as geometrical tolerance, which are mentioned on engineering drawings. So we need to have a knowledge of these things in order to understand drawing better, because if you are not able to read the drawing properly, then it can create problems in the manufacturing. So understanding, interpreting the drawing is very much important for an engineer who is working in a shop floor, who is working in manufacturing environment. That's why we call drawing as in communication language. So this is how actually your engineering drawing will look. So this is the drawing of the object, which has been given some dimensions that we are able to read easily. Okay, it's like this is 100, this is 35, this is 50. The problem with the student is they don't understand what these rectangular feature frames are talking about. Okay, so the motto behind learning GD&T symbols is to understand these rectangular feature frames. So as we have discussed previously, the geometrical forms. So this is the symbol for position, this is the symbol for profile, this is the symbol for flatness, this is the symbol for perpendicularity, this is the symbol for perpendicularity. So these symbols which are there in the first frame are talking about geometrical features. The rest is the geometrical tolerance, and this is the datums. Okay, so let's see. This is a rectangular plate which is having one hole here. So this rectangular frame is talking about the position of the hole, because this hole will have some center. So as per the drawing, the center will be at x coordinate 35, y coordinate 25. So your center should be at 35, 25. That is what expected every time whenever you are drilling a plate, or whenever you are drilling a hole on this plate. Okay, diameter is not given, so we are not worried about diameter. We are worried about the position of the hole, which is supposed to be 35, 25. But what this rectangular feature frame is talking about, this rectangular feature frame is talking about I can allow a tolerance of 0.04 over, or sorry, I can allow diametral tolerance of 0.04 on maximum material condition with respect to three references: reference A, which is primary reference; reference B, which is secondary reference; reference C, which is an tertiary reference. Right? So deviation in the position is allowed up to only the value of 0.04. This is what in x direction, in y direction, as well as in z direction. That is what this is rectangular feature frame is saying. That means your center can deviate in y side, in x side, or in z side by this value. This is what I am saying. So your center can be at 35.004, 25, or it can be at 35, 25.004. This is what this rectangular feature frame is talking about. Similarly, see here, this dimension is 20, and this face supposed to be flat. But while machining, I can give a tolerance on the flatness with the value of 0.01 with the datum A, which is a primary reference. Right? Similarly, this symbol is talking about the perpendicularity of this surface. This is talking about perpendicularity of this surface. So this is what your engineering drawing will be, or your engineering drawing will look like this. So the drawings can get complicated by adding the GD&T symbols, because GD&T symbols will make your drawings complete. Drawing is not about only having the dimensions in front view, top view, side view. It's very important to know the front view, top view, side view, but along with that front view, top view, side view, there will be GD&T symbols on your drawing, which will make your engineering drawing complete. This is what shop floor or production shop floors accept. So if you want to spend good time in production shop floor, it is very important that you learn to read such type of drawings. This is very simple example. The examples can get tougher and tougher, but again, this is very basic thing that I am discussing with you. So thank you for listening.